Hey guys, today we're going to solve LeetCode number 54, spiral matrix. So we're given a matrix of m times n elements, and we need to return all elements of the matrix in spiral order. So we want to take like the first row, then the last column, and then the last row in reverse, and then the first column in reverse. Okay, so there are many ways to do this. One way given by Just.Poccio, which is a great competitive programmer, is to always take the first row and then rotate the matrix counterclockwise. So that's a great solution, like it's very creative. However, we're going to go for the simpler version, the simple solution, which is optimal in a time complexity and space complexity analysis. So to do this, what we're going to do is we're going to keep track of which rows and columns we have consumed. Like we want to think of them as being now out of bounds, right? So for example, if we take the first row and we put those elements in the array, then we want to say that now we have an upper bound that is 1. Like we can't go any further upwards than 1. 1 is our first row now. We can't access this 0th row now, okay? So yeah, we're going to need some variables to keep track of those bounds. And then we're just going to use for loops to take the first row that is in our bounds, and then the last column which is in our bounds, then the last row which is in our bounds, and then the first column which is in our bounds. So that will go around in the matrix clockwise. Okay, so let's jump right into the coding. So first of all, this is a line for a edge case where you don't have basically any elements. So in that case, you just want to return an empty array. But then here starts the real coding. So here you have the bounds for the left side, so the starting column, and the ending column. So these are the bounds for the left and right bounds. And initially they are 0, so you can start with the 0th column. And another valid column is, for example, here, it's the column with index 2. So it's the third column. Then you have the same thing for rows. So the 0th row, the first row, so the one with index 0 is valid, and the last row that is valid is the row with index 2, so the third row. Okay, so these are our 4 bounds that will tell us if we can move any further in that direction. Now we need the result array. This is going to be our output. And now what we're going to do is we're going to use a while loop. So while our result length is less than the amount of elements in our matrix, which is just kind of like n squared. It's like the base length times the height. So yeah, what I was saying is while our result length is less than the amount of elements in the matrix, we're going to run 4 for loops to take the first row, the last column, the last row, and the first column. So the first loop here is going to loop through from the bound, from our left bound to our right bound, is going to take all of the elements in our upper bound row. So like our upper bound row initially is 0, so it's going to take all of those elements, but then it's going to move further down, right? So yeah, we're going to use our upper bound as a row index. So you can see I'm using my upper bound as a row index in my matrix, and then I'm using the column bounded by the start and end column as a column index. And I'm just pushing it into the result. And now, like here, essentially we've consumed the matrix row, so we can add 1 to the start row because we don't ever want to touch this row ever again, or we will have duplicates, right? So it's very important that here we do start row plus plus. And then like the remaining 3 for loops are going to be very similar to this one, so I'm going to go very quickly with them. So start with your upper bound and go down to your lower bound, and use that as a row index, and push to the result the element in that row at index and column. So that's your right bound, right? So we're traversing down the last column, which is in our bounds. And at the end, decrement your end column because you want to move it closer to the center of the matrix, right? You want to close in on the center. And yeah, so it's basically the same thing for the last 2 for loops. You can kind of see they're the same thing. Here we're moving from the end column down to the start column. So we're moving in reverse order, and we just push the element like before. And the same thing here. We start from the last row, and we go up to the initial row, to the upper bound, and we push the element again. And don't forget to update the bounds, because you're using up the elements. You don't want to use them again, or you'll have duplicates. Okay, so now we can just return our result array. And since we're doing this in this way with for loops, you might actually end up with more elements in your result array than there are elements in the matrix. And so what you want to do is you want to trim down the result so that it doesn't have any more than this amount of elements. And so to do that, I use the slice method. So I take the whole array, and I don't want to take any elements that are above this, right? So I'm going to show you that this works. And the time complexity here is O of n squared, or like O of n if you take n as the amount of elements in the matrix. And the space complexity is O of n, where n is the amount of elements in the matrix, because we're storing them in the output. And if you don't consider the input and the output as the space complexity, then the space complexity here is O of 1, because we only have these 4 variables, and they don't occupy more memory based on how many elements the matrix has. So yeah, that's it for me today. Thank you for watching, and bye.